So many times I'm asked what is a circulator. We call a circulator, actually it's a pump, but it's called a circulator pump when it's asked to work in a closed loop circuit. So as you can see, this is a circulator with the suction and the delivery that are aligned each other. This pump is supposed to work in a circuit, so pipe in, pipe out, closed loop, where the water recirculates, and this is typically for application of air conditioning and heat exchange. So what is different in a circulator compared to another pump? We said about suction and delivery, but also it's different the technology inside the pump. Usually circulators are wet rotor pump. That means there is not a mechanical seal. The water that passes through the wet end goes through into the motor to cool it down. And that's the reason why the circulator can never be installed in this position, because the water don't goes up enough to cool down the motor. So the circulator must always be installed with the shaft of the motor in a horizontal position. Okay, so this is a little hint about circulator. Then another main difference of circulator compared to other pump is the value of the pressure that they can generate. Being in a closed loop, actually we don't need that much pressure. We just need a little amount to win the pressure losses that the pipeline and the friction over the pipeline creates for the flow. Usually, the pressure generated by a circulator is about 5 meters, 10 meters, or 15 meters. It's about 150 kPa. Yeah. Compared to a booster pump that must pressurize the water into an open circuit, they can operate at 30 meters, 40 meters. We are about 10% of that pressure. And how to read the curve of a circulator is actually easy, because the curve of a circulator is exactly the same of a curve of any other pump. So nothing is changed from this point of view. The typical shape of the curve is highest pressure when the flow is the lowest, or highest flow when the pressure is the minimum that the pump can provide. Based on the information, you will find the point on the curve where the pump is working, and you will find the performance that the pump is giving to you. One thing about this circulator, actually, it's a little bit heavy. Just give me 1 second. This is a 3-speed circulator. It's called BPH from the pump. So here, under this box, you can actually set a switch into speed 1, speed 2, or speed 3. What's the difference? There are 3 curves that are actually parallel each other, set it in different performances. So we have the lower curve is the one where the pump gives the lowest performance, and then we have curve number 3 where the pump gives the highest performance, but always with the same, let's say, shape of performance. So yeah, this is a way to adapt my pump to different needs that I might have in my application.